All right, going over our do now for today. You should have got your amplitude is that coefficient or that A value. So your amplitude in this situation is going to be 2. Remember, it's absolute value, so even if that were a -2, it would be a +2. Your midline is where am I starting my points from, or where am I always kind of coming back to? And that is going to be that -3. Remember, your period is always going to be 2 pi divided by that B value. So your period is going to be 2 pi divided by pi over 2. Because that doesn't look super neat, I'm going to say 2 pi over 1. Remember, when you're dividing by a fraction, you flip and multiply. So times 2 over pi. Those pi's cancel out, and I get that my period is 4. That means for that cosine graph, if I were graphing it, 1, 2, 3, 4, it would complete all those values in 4. Your domain is always going to be all real numbers. These are cyclic functions, which means that they continue on and on and on. They keep on cycling through the values. So domain is all real numbers. And range, remember we talked about that yesterday. Because I'm starting off at -3, and from that -3 I'm going 2 above and 2 below, my range is going to be -3 minus 2. So -3 plus or minus 2. Which gives us a range of -5 to -1. -5 to -1. Number 2, on the coordinate plane provided, sketch a sine function with an amplitude of 1 period of pi, midline of y equals -2. So let's get that graphed on here. And passing through the point 0, 2. All right, amplitude is 1, so we're going to be cycling between our range, which is going to be -3 to -1. I also know we need to pass through the point 0, -2. Now let's get this written first so I can start graphing. I know that this is going to be sine, it's going to be a 1 in the front because my amplitude is 1. I know that this is going to be a -2. And I know that also that my sine curves should act like this. If I were to plug in a 0 for the x value, my y value should be -2, so that is good to go. My period is 2 pi. You know that whatever your period is, or your period is pi, 2 pi divided by what needs to equal 2 pi? Needs to equal pi, my goodness. So I know that this value, I don't know what it is yet, but I know that when I divide 2 pi by that, I get pi. So we should fill in that this b value, or this missing value, is going to be +2. We are moving twice as fast. So now I can get this graphed. I'm going to label my x-axis pi over 4, pi over 2, 3 pi over 4, and pi. And I'll do my points over here just in case. You guys should probably be able to graph it by now, but let's see. We should have started off with 0, 0, so this is our original sine of x, no transformations. Pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. Now remember, for our x values, we are doubling the speed, so we're cutting that x value in half. Remember, we're always doing the opposite for our x values. So our vector right here, we're doing, instead of multiplying by 2, we're going to do x divided by 2. So that is 0, 1/2 times, or pi over 2 times 1/2 is pi over 4, pi over 2, 3 pi over 4, and then 2 pi divided by 2 is just going to be pi. Our y values, let's get a little bit more room here. Your y values, you're shifting down 2, and that is it. That is the only y transformation happening here. So I'm going to say y minus 2. And from that 0, we're going to go down to -2, which meets that condition, so we're good to go. From that 1, we're going to go down to -1. Then we're going to go back to negative 2. Negative 2 minus 1 is going to be negative 3, and then we're back to that negative 2. So let's get this graphed. We should have 0, negative 2, pi over 4, negative 1, negative 2, negative 3, and back. Make sure that you are, let's make that a little bit neater. I should have gone through those points a little bit better. There we go. And you would just be cycling through those values. Graph the function. Great. Okay, let's get this done. We know that we have solutions at negative 1, 2, and 3. We also know that this negative is going to flip our end behavior rate. Your degree is x to the 1, 2, 3. So if I multiply that all out, I get negative x cubed, which means that my end behavior is up, down. So I'm just going to draw an up here, a down here. Because the degree of each of these factors is linear, that means I'm passing through, I'm not bouncing or crossing anywhere. I can also find my y-intercept. So f of 0, if I plug in a 0, that's going to be negative 1 times negative 2 times negative 3. So we get negative 6. And then I'm just going to pass through all these points and get that drawn. Write the end behavior in proper notation. So let's just say right here, as x approaches negative infinity and as x approaches positive infinity. Remember, this negative infinity is just saying what's happening on the left. This positive infinity is just saying what's happening on the right. F of x goes to positive infinity, and f of x approaches negative infinity because my y values get really, really big on the left-hand side and really, really small on the right-hand side. Last one, we are evaluating. So let's try to do this by memory. I know that cosine of 2 pi over 3, 2/3 is going to be less, so we're looking at something like right here. We can also make some assumptions on what these values are going to be. So 2 pi over 3, I'm going to draw that again. So if I had my unit circle, remember we're going 1/3, 2/3. So I know cosine is my x value. If I were to walk down, that looks to be about halfway through the radius. And if I do check my unit circle, I get that that is negative 1/2. Remember, cosine value is negative because we are in quadrant 2. Sine of 5 pi over 4. Remember, that's going to be 4 pi over 4 is pi. And then if I go a little bit more, that's going to put me at this guy. Remember, those halfways always have the same. They're always root 2 over root 2. Also, because they're in quadrant 3, they're both negative. So my sine is negative root 2 over 2. Tangent of pi over 4. So I know that 1/4 here is going to be my pi over 4. I also know that that ordered pair is going to be positive root 2 over 2, positive root 2 over 2. Tangent is sine divided by cosine, so positive root 2 over 2 divided by positive root 2 over 2 is going to be positive 1.